Who start? You could, yeah, okay, please start the recording. Okay, so it is my honor to replace Yafim, who is traveling now, but he listens as a host of this meeting. It's an honor to present Joerg Rieskamp, who is the head of the Center of Economic Psychology at the University of Basel. Joerg finished his PhD at the Max Planck Institute for Human Development. He then spent some time as a postdoc at the University of in Indiana University, and he co-authored many influential papers on that extend the focus of decision from experience. And his paper was appeared in the best journal, includes Psych Review. Training in Cognitive Psychology, recently Science Advances, several papers in Psych Review. And he also had very good students. One common student with me, Doron, and now they have a paper that might appear that has good chance of appearing in Management Science. So now we're going to hear more about Joerg's research. Joerg, you have 45 minutes and then 15 minutes for question. And then we'll have another 15 minutes informal discussion. So most people will leave after an hour. So, and the floor is yours.
Yeah, thank you very much. I'm giving you an overview of some work that people in my center have conducted, including Renato Frey, who's now in Zurich, and Steve Heinke, who is in Fribourg, and Sebastian Olszewski, who's also joining us today, so maybe he can give some smart comments to some of the work that I'm presenting. As I said, these are different projects that I'm presenting today. I hope that the time is sufficient to give you a little bit of an insight. Okay, so the more general title is risk tolerance, risk taking, and investment behavior. So we are focusing basically on human behavior, making decisions under risk. And here the question is, how do people do this? And to what extent does this also involve their risk attitude, their risk tolerance, their risk preferences? So a typical example of a decision under risk is in investment decisions. So here we make the decision whether we want to invest in stocks. Stocks offer us a higher return, but at the same time, they also come with higher risk or volatility. And now people have to make a trade-off between the return and the risk. And of course, this depends on people's personal preferences. So basically, it depends on their risk tolerance, on their attitude. So that does not only apply to investment behavior, but in many areas, traffic behavior, medical decisions, they all depend on people's risk attitude. So whether you are willing to take a risky medical treatment depends also on, or should also depend on your risk attitude. But today I'm more or less focusing on investment behavior and on monetary decisions. So if we, sorry, give me 1 second. Sorry, I had to open the door for my child. Anyway, so people's decisions under risk depend on their risk attitude. And the question is, how can we access, how can we reliably measure a person's risk attitude? This is one project that I would like to present to you. This is a bit some older work, but I'm showing this to you because it also is influential for some of the work I'm showing you afterwards. And basically, there are two traditions on how people measure people's risk attitudes. Either they rely on self-report questionnaires, that's strongly influenced by psychological research, also by clinical researchers. And on the other hand, we have behavioral measures. Experimental economists are, of course, more behind these measures. So these are different traditions. And the question is, okay, how good are they in measuring people's risk attitudes? And an example here, for instance, the domain-specific risk attitude scale by Elke Weber and colleagues. And I guess I don't have to explain this in detail to you, but the people that I see here in the audience are quite familiar with these techniques. So you basically just have a questionnaire, you have a hypothetical situation, and you have to express to what extent you are willing to take some risk or not. Now, this is a way how you can assess people's willingness to take risks using questionnaires. And on the other hand, you have more behavioral methods. A standard technique in experimental economics is the use of multiple price lists. As you can see here, this is a Holt and Lowry price list that has been widely used in experimental economics, but also in psychology. So now the question is, how good are these measures in assessing people's risk attitudes? And what we did, we had a relatively large study with more than 1,000 participants, and they all had to go through these different measures, and we were interested in figuring out to what extent they are related to each other. And here is the result of the correlations of these different measures with each other. And I'm not going into the details of each single measure, but what you can see is the difference between the red and the blue measurements, and the blue ones are the behavioral measures, and the red are the self-report measures. And interestingly, the self-report measures are more stronger correlated with each other than the behavioral measures. So they seem to be a bit different. Now the question is, okay, how good or how reliable are these measurements?
Can I just clarification question? So the behavioral measures are all some of them decision from description, some from experience?
Most of them are decisions from descriptions, but we also had experience-based measures. But most,
This
well,
one is
not.
just
I mean, so for instance, we had the BART task as an example, and that's also an experience task, right? Where you have to figure out when a balloon explodes, for instance, that the probabilities when the balloon explodes is not given to the participants, but has to be figured out by learning. So
and there are
therefore,
100 tries usually in BART, so there is some experience for sure, right?
Yeah, sure. So what I'm saying is we have a mixture of behavioral measures. Some of them rely on experience. Others are, as you have seen, the multiple price list by Lowry and Holt does not rely on experience, but just on description. And what you see here is that retest reliability. So we invited a subset of the participants in our lab again, and they had to do the whole test again 3 months later. And on the x-axis, you see the retest reliability, so the retest correlation. And as you can see, those are not extremely high. So, and what we also see is that the self-report measures have a little bit higher retest reliability. So also some of us believe or might have a tendency for the behavioral measures because they are connected with real consequences. They are also incentivized. So we think maybe that's a better way of measuring people's risk attitude. On the other hand, we see that the self-report measures have a higher retest reliability. So there seems to be an advantage in self-report measures as well. So overall, this result is not very, well, it's worrying because we observe that some of these instruments have a really or relatively low retest reliability. Meaning, if I measure someone's risk attitude and I do this 3 months later, the result might turn out to be quite different. However, is there a solution, or how can we solve this problem? One solution that we favored in this work was to perform a factor analysis. So we basically did a bi-factor analysis. And this R that you see down here, or we claim that this R factor represents people's overall risk attitudes. And when you combine these different measures with each other and to extract one factor, you might have a more reliable measurement of people's risk attitude. And indeed, and that's what I show here with this red arrow, a combination of different measures might lead to a more reliable measurement of people's risk attitudes. And that was one major conclusion from the study. And that's why I showed this to you. So one final conclusion from this paper was, when combining different measures, a reliable measurement of a person's risk attitude can be achieved. So my suggestion, or our suggestion, is, well, maybe we shouldn't just rely on single measurements, but have different measures and combine them, and then we have a better idea of people's risk attitudes and preferences. And this is also something that we followed in a more recent project, which I will explain to you next. And then in this more recent project, we also had a relatively large study. So we were able to analyze the portfolios of the customers of a Swiss online broker. And overall, we analyzed the portfolios of 140,000 customers of this bank. But on top of it, what we were able to invite them for an experimental study, to our lab, in which they had to perform a lot of cognitive tests. And these are the tests that so we have cognitive ability tests, we have a present bias test, we had self-control tests. So not only risk aversion, but other cognitive and motivational factors were accessed in this relatively large study. Okay, and now we were interested. I can't go into the details of this overall study, but I wanted to show you, okay, to what extent is the measurement of people's risk preferences relevant for describing their investment behavior. And first of all, we analyzed the portfolios of these customers. We did this for the whole sample, but we also did this for the subsample for the ones who we had in our laboratory. And it turned out that the average excess return relative to a riskless Swiss government bond was 2%. So when we look at the returns and subtract the return of a safe Swiss bond, then the average return for a period of, we had the opportunity to analyze their portfolios for 4 years. And for this period, we had an excess return of 2%. We also analyzed the risk, or the standard deviation of their returns, and that was relatively high with 38%. So overall, I said that at the very beginning, when people make decisions under risk, they should trade off return to risk, right? So you might be willing to take some risk, but only if you get some higher return for this. So that's this risk-return trade-off that I've tried to illustrate with this figure. And this trade-off does not look very beneficial for our participants. So what we observe here is a relatively low return, but on the other hand, relatively high risk. So their portfolio on average don't look so good. And the question is, can we explain this a bit with the measurements that we took?
Can you explain again where the blue line came from?
Well,
This
that's just
was,
an illustration. That's no data.
oh, but could be
I'm
that in
just
this
saying, well,
period it was impossible to get such a, maybe it's only a feature of the period, not of their behavior.
That's right. I mean, that's a good objection. So you could argue, well, is that really possible to have this large return given the variance? And indeed, I show you this later to you. If they had just bought the market, they would have had a higher return with lower risk. Yeah. So we can evaluate this risk return combination relative to the market during this period. And I'm showing this later on. But indeed, you're right. I mean, this blue line is just an illustration, so it's no empirical data behind it. But in principle, the risk, let's say, finance argues, well, there should be a correlation between risk and return. That's a theoretical argument. Let's go into this a bit in some more detail. So what we measured, we had different measurements. So all the participants, besides that we had their portfolio, we also invited them to the lab and they had to go through these different tests. That took them a while. So we had different batteries and they completed them over a period of some time. But what's important, we also measured people risk aversion. But following this first study, we did not use one single measure, but we applied a factor analysis in order to create these 6 factors that I'm presenting in bold font here. And what you see here are already the results on the Y. So on the left side here, we see the different factors like risk aversion, self-control, present bias, and so on. And now we analyze, we had basically a regression model. We relied here on Bayesian averaging. But nevertheless, we had a regression model that told us to what extent people's risk aversion is related to their performance. And the performance was split in return and variance. Yeah, so we said performance is the return minus basically the risk. And what you see here is the impact of these 6 factors on excess return and variance or risk. And as we can see, risk aversion, self-control, and present bias are the ones that are important. And in particular, we see the impact on risk aversion on the risk of the portfolios. So those participants that we characterize as being relatively risk averse had a lower variance of their portfolio. As you can see, these 6 factors were not strongly correlated or were not able to predict their returns, but they had an impact on the risk of their portfolio. Likewise, we also see that those participants with higher self-control took less risk. And present bias was the last of these 6 factors that also had a slight impact on the risk, in the sense that those with high present bias took more risk in their portfolios.
Joerg, can I ask a question?
Sure.
If I understood correctly, so the risk aversion dimension was assessed by several tasks, including self-reports, right?
Yeah, here we had different measures, and in the end, this measure is
Combined.
it's a combination, but it's more a self-report measure here that turned out to be the best predictor.
Because in a self-report measure, they might even ask you if you tend to diverse your investment, right? This is part of.
In principle, that could be, yeah. There was also a question about financial decisions. I agree.
Okay. So that could be why this turned to be more predictive, right? In a way.
Well, I don't think I mean, this is a measure. The risk aversion measure is composed out of different components, so it's unlikely that only this single question drives this correlation.
Yeah, sure.
So maybe I want to emphasize a bit what Kinrat said. Even there are these introspective questions, they are closely related to what you want to predict. So in that sense, it's not very surprising that they predict well.
Can you explain that again?
It's what Kinrat already said. If it is introspective question, ask you things like how afraid are you if you invest money and maybe other things. These things are just close to the investment decision themselves. So it's not surprising that they predict.
Yeah, in some sense, you're right. I mean, so it could be that since these questions are more related to investment decisions, it could be that one of the factors that drives this correlation. That's could be the case. I agree. Yeah. Nevertheless, so we found this correlation that those. I mean, it's a good finding, basically, right? So we had 6 factors, and at least we found a few of them that were related to people's real investment behavior. So that's, for me, that was a positive finding, that we can use some measurements that are established, that have been used before, and they allow us to predict real-world investment behavior. Yeah? Whereas the term predict, okay, I understand, has to be.
You did the same thing.
Basically, a correlation.
Sorry, did you look if the Holt and Lowry also have this nice feature?
Now, we could not find that for the Holt and Lowry here.
So that would be important to make people know, because it's such a popular measure. And if it's not correlated to investment decision, you have nice results. This is very nice, but this is important results, because so many people waste their time measuring Holt and Lowry, and if it's not correlated, they should know that.
Yeah. What we also checked.
Maybe
I want
to protest a bit against what Ido says. It's indeed this Holt and Lowry that are better Tversky-Cannon measures called. But anyway, they are related to normative theories, to wise decisions. That makes them much more interesting. These introspective questions are just asking the same as what you want to measure. That's even if they have the statistical property of correlation is lower, they are much more interesting and valuable, contrary to what Ido suggested.
Okay, I'm not going into the details of this debate now. I'm just, we observe that there are different measurement tools and different traditions, and we are not the only ones who have tried to evaluate these different tools. And I'm just reporting the results to you. And now I understand that one can interpret these results differently. Okay, but move on, because I have to move on. This is I've a few more things to say. One thing, what's interesting in my view, is when we look at investment behavior, there are 2 types of risk. On the one hand, people in finance distinguish systematic from unsystematic risk. So exposure to market-wide and macroeconomic factors that impact all investments, that's called systematic risk. So if you allocate money to bonds versus stocks, the larger the proportion is for stocks, the more systematic risk you take. And here the assumption is that the higher systematic risk you take, the higher the return should be that you have. On the other hand, we have idiosyncratic risks, factors that are unique to an asset, to a company or country. And higher idiosyncratic risk does not lead to higher returns.
You're muted.
Sorry. So here, the risk-return trade-off does not hold. So if you take more idiosyncratic risk, that does not mean that you will have higher returns. So if you are confident, so let's say you're interested in the US market, maybe the NASDAQ, and you can decide how much of your portfolio you want to invest into the NASDAQ and how much you want to invest in bonds. The more you invest into the NASDAQ, the more systematic risk you take, and that will be compensated by a higher return, the risk that you take. However, if you think you're very smart and only select a few companies from the NASDAQ, what you're basically doing is you increase your idiosyncratic risk, and that might not be compensated by higher return. That's the idea between systematic and idiosyncratic risk. And now what we did, we decomposed the risk of our participants, and what we observe is that only 21% of the average portfolio variance can be explained by stock market fluctuation, so systematic risks. And so the large proportion of the portfolio variance consists of idiosyncratic risk, of our participants. So you can distinguish these two types, and what you then see is that risk aversion, self-control, so these two important factors that I already presented to you, are highly correlated to idiosyncratic risk. So those who are very risk averse, they take less idiosyncratic risk, which makes sense. And those who are very risk tolerant take more idiosyncratic risk, but again, idiosyncratic risk will not be compensated by higher return. So those people who take more risk in our subject pool are not compensated by observing or receiving higher returns. Again, we have risk control, but we also have an effect of self-control and a smaller effect of present bias. And that brings me back to Ido's question. So what we basically observe is that the returns of our participants are relatively low, but they take a lot of risks. And these risks are not compensated. Why is that? Because we observe that about 80% of the risk that they take is idiosyncratic risk, and that's not compensated by higher return. This proportion strongly correlates with their risk attitude. So those who are very risk tolerant take more risks. But again, note, this risk is not compensated by higher returns. And what I call free lunch here is the idea they could have had a much better portfolio by not taking so high idiosyncratic risk. They could have just taken the market portfolio. I think this is here the Swiss market return for this 4 years that we analyzed. And if they had just chosen that, they had received a performance of 10% and lower variance. And in this sense, this blue line is not just an illustration, but relies on empirical data. And just to answer Ido's question now. So, what we see here, we can measure people's risk attitude. We use self-reports for doing so. That's what we observed in the first study. Self-reports are a bit more reliable. And by using these self-reports, we can the results are related to people's real investment behavior. We see in their portfolio that those with high risk are the ones that are risk tolerant, and those with low risk are the ones that are more risk averse. But this correlation refers more to idiosyncratic risk. Idiosyncratic risk means, for instance, stock picking, where you think you're confident in selecting a few stocks, but that basically just, on average at least, increases risk without being much compensated by higher returns.
Can you explain more about the idiosyncratic? This is really interesting.
What do you mean?
How do you measure it? Like, how do you differentiate from real risk? Like,
So the way you do this, you take the variance of the market portfolio, and then you take the variance of the portfolio of our subjects and see to what extent this variance of the portfolio can be predicted by the variance of the market portfolio. And thereby you can decompose this variance in two components, one that is correlated with the market portfolio variance and one that is beyond that variance, and that's called the idiosyncratic risk.
so in other words, it's all kind of psychological factor that affect the perceived risk, but not affect the actual risk in the market.
No, not sure whether I understood this correctly. So what we have the variance of the portfolios of our participants, of our customers, of this online broker. And now we want to find out, okay, to what extent is this risk, the variance that we observe here, made out of systematic risk and idiosyncratic risk. And the systematic risk is just defined by the variance of the market portfolio. And we have that variance, and then we can correlate that variance with the variance of the portfolios. And the one that is explained by the market variance, that's what we call the systematic risk. And everything that's left over is called the idiosyncratic risk, without explaining what that really is, to be honest. Yeah.
But behaviorally, the idiosyncratic risk are people just go for individual stock instead of going for, they're basically under-diversified.
That's right. So basically, they are under-diversified. I completely agree.
Maybe this is not a finance, so maybe good. As I understand, idiosyncratic risk has the same returns as market risk, but it only increases the variance more without getting, it's not worse in return than market. It's equally good in return as market, but only it has more variance.
It had much more variance, yeah. You're not compensating, yeah.
Well, in these 4 years, it was less, but on expectations, they're the same.
But in your figure, they have lower risk, lower return.
Yeah, because only 4 years.
Okay.
So usually, if you increase idiosyncratic risk, it is assumed that this will not be compensated by higher returns. Whereas if you switch from bonds, for instance, with a low return, to, let's say, a large proportion of stocks, then you increase systematic risk, and that means you also increase the return.
So, so in other words, it's mean the idiosyncratic that you diversify, but in some dimension that are not relevant for the market.
Exactly.
You do not really. I mean, the problem is that you're under-diversified.
Yeah.
Maybe if I can be a bit like chairman, maybe we should go on now.
Okay,
sure.
You can be my what do you say? You can replace me as in that front.
So I think I have taken already too much time for these two projects, so I have to rush for the last one, because what I want to present to you on top of this, these are large-scale studies where we analyze the portfolios of customers of a bank, But we do think, in order to understand in detail how people make decisions, we need to understand the cognitive processes underlying decisions under risk. And in this last project that I'm showing to you, which is together with my co-authors Sebastian Olszewski and Melvin Martin, we developed such a model that should describe people's the cognitive process underlying decisions under risk. So, and this is a situation like that most of you are very familiar with. So let's say you have different lotteries and you have to decide which lottery you prefer. And now the question is, how can we describe the cognitive process underlying these decisions? And you're all familiar with standard models of risky choice. So you all know expected utility theory, mean variance models, rank dependent utility, cumulative prospect theory. They can, to some extent, explain context effects, but not all of them. And one of the main feature, to different extents, but is that they assume that when you have these two lotteries, that you can form an evaluation of one lottery independently of the evaluation of the other lottery. And there are alternative models like regret theory or the priority heuristic or other heuristics that have been suggested, or distracted decision field theory, that assume that the context matters, context in the sense that the presentation of an alternative can be perceived in the context of another alternative. And that's what one can call context-dependent evaluation, if it depends whether a lottery A is presented in combination with another lottery, let's say B or C, and that might have an impact on the subjective value of lottery A.
And context dependent is typically violating transitivity.
Yeah.
So that's the thing, yeah.
So there are different, this term that's always a bit problematic. This term context dependent or context effect is always sometimes defined a bit differently. Here we define it in the sense that the evaluation of an option might depend on alternative options that are also present. And if these effects occur, then transitivity might be violated, as you just pointed out. Yeah. Okay, and as you see, here are some of these models that assume these context dependency. And we suggest a new model, and I'm trying to quickly present this to you to show you that people in Basel are also very much interested in understanding the cognitive process that leads or that underlies people's decisions under risk. So the model that we have here is a so-called noisy comparison model. And we assume that people make comparison across options when making risky choices. These comparisons are noisy because cognitive processes are imprecise. And this imprecision can affect both utility differences and probability representations. Let's start with the probability representation. So the model assumes that you do not take the exact probabilities, but that there is always some noise included. So if the correct probability is P, then you take basically the average of 1 over n. N is the number of outcomes. So if you had 5 outcomes, the probability would be, the naive probability would be 20% for all 5 outcomes, but the exact probability might be 10%. And now you take the average of this 20% and 10%. So the representation of the probability is not exact. And depending on this parameter, you have either relatively accurate representations of probabilities or more naive representation of probabilities. That's a representation of probabilities. Then on top of it, we have noisy representation of utilities or of outcomes. First, we take the outcomes and have an utility function, a power function that represents outcomes, and that's the utility of the outcome. But what we then do, we are not, as an expected utility, just take the utilities and use them to evaluate the option, but we compare the utility of one option with the utility of the outcome of another option. And again, we take this difference and we take it to the power of sigma here. And by doing so, there also comes some noise in this comparison in representing this difference. And what we then do, we take these probability representations that are noisy and the comparison of these outcomes that are also noisy, and weight these differences, these utility differences, with the probabilities of these outcomes, and that provides us with an overall subjective value of one option over the other option. And now we take a choice rule, a softmax choice rule, to determine with which probability one option is taken over the other. And that's a noisy comparison model in mathematical terms. Okay. And now I have to be very quick in showing you the results for these studies. Maybe I show you just one of the experiments.
Yeah, but because we ask you a lot of questions, you can use a question time now to present.
So maybe I need a few minutes anyway. So what we gave participants is the choice between two gambles, as you can see them here. Yeah. And what we fixed was the expected value of both gambles and also the variance, but we manipulated the skewness. And these gambles were dependent gambles, meaning that there's one event that occurs with a probability, for instance, of 70%. And if this event occurs, then with gamble F, you receive $59, and with gamble G, you receive $36. If you have these dependent gambles, it's natural that people might compare 59 to 36. So you can do these comparisons. And we manipulated some aspects of these gambles. So for instance, we included an extreme outcome for one of the gambles, or we reduced the range of the outcomes for one gamble, or we changed the middle outcome for the non-skewed gambles, or we created a negative correlation between the outcomes. So these are all aspects that should more or less be irrelevant if you follow an expected utility model that evaluates options independent of each other. However, if you do these comparisons that I showed to you, then these comparisons will be influenced by these aspects. And now we were interested in finding out, okay, do they have an effect? And is our model able to describe these effects? And here are the results. And the results show us that indeed these different aspects that I just presented to you have an impact on people's choices or their preferences. And so on the y-axis, you always see the preference for the skewed gamble. And the different symbols here illustrate how good the different models that were fitted to the data using Bayesian techniques were able to describe these different preferences. And we use the noisy comparison model, but we also use the mean variance skewness model, the rank dependent utility model, regret theory, and decision field theory as comparisons. And this figure might not make this completely clear, but if we take the overall fit of the models, at least for this experiment, the noisy comparison model turned out to be quite well, did a quite good job in predicting the observed findings. Not sure whether I'm not explaining this right now. I maybe go to a second experiment in which we were interested in finding out whether the model would also work for independent gambles. Yeah? So where there's not one single event that determines the outcome for both gambles, but where this is more or less independent. And this is the way how you can do this, or how you can present this. So on the left side, we see dependent gambles with 5 different events that occur with some probability. But you can also split them and say, well, these are independent gambles. Also, the probabilities are identical. You could nevertheless say these gambles are do not depend on joint events. Yeah? And since some of these outcomes are identical, this allows us to combine them, or they can be coalescent, as it is said. And that's what we have done here on the right side of this figure. So basically, you have the same identical lotteries, but you present them in a different way. Or, well, if they are dependent, I think I cannot say they are the same. But if you evaluate these gambles independently with an expected utility model, the same result should hold. Yeah? Of course, if you have independent gambles, the different comparisons that our model assumes will change. Where if you have dependent gambles, you would assume that you only check outcomes for identical events. Whereas if you have independent gambles, you need to compare all outcomes with the outcomes of the other gambles. So you do much more comparisons. Yeah. What we see here, that the way how you present these gambles has an effect on people's preferences. So unlike models that assume independent evaluations, we see that the way these gambles are presented has an effect on people's preferences. And we also observe effects of these different manipulations of the gambles, but due to the time, I'm not going into the details here. One more, presenting the last study, is a reanalysis of the data by Peterson, a paper in Science, in which they analyzed a very huge data set, many choice experiments, and they tested a large number of theories to explain this data set. And we thought, well, I presented you 2 experiments where we manipulated some aspects of the gambles to illustrate the mechanism of our theory. But nevertheless, we thought, well, we should also show how good this theory is to explain decision-making under risk in general. And we thought that this data set might be quite useful for this. And therefore, we also fitted our model to this data set. And the way they do this here, they always use part of the data to train the model, to fit the model, and then make predictions for the left-out data set. And that's also what we did. So we used 90% of the data to train the data and then made predictions for the remaining 10%. And what you see here is the blue overall line. That's the predictive accuracy of the noisy comparison model or theory that we propose here. And overall, it does quite well in comparison to the models that had been suggested for this data set. So therefore, we also think that this model might be a relatively accurate model in describing decision-making under risk in general. And with that, I should come to the conclusions. So our model assumes noisy comparison processes of utility differences between lotteries, can explain new binary context effects in risky choice. Some of them I presented to you. I did not explain this, can also explain some choice anomalies. And it provides a good quantitative fit in a big risky choice data set. That's a Peterson data set that I presented at the end. What we observe is that the binary choices are subject to context effects. Again, people define context effects a bit differently, I admit. And descriptive model of risky choice need to take these context effects into account, and the noisy comparison theory that we suggest is able to do so. And with that, I would like to thank you for your attention.
Great, thank you. We have 8 minutes for questions, so this is fair enough because we did ask more questions in the, so we're doing fine. So Peter, as a
Yeah.
senior chairman, you should be
Yeah.
first.
Well, I have a question to Joerg. It's in the third part of your presentation. I wonder how you corrected for the number of free parameters used in the models. For instance, this Peterson et al. Study, they do a prediction exercise. Many people say then you correct for number of parameters, but I think it's not true. The Peterson et al. Result can very easily be summarized. The more parameters, the better, because there's such a big data set. So in general, my question is, how did you correct for number of parameters in your models?
So in the Peterson dataset, we followed their approach of cross-validation. And you already pointed this out. So we use parts of the data to fit the model. And of course, you can discuss how large this data set should be for training. But you use parts of the data for training, and then you make predictions for the remaining data. And implicit, I mean, this is cross-validation. And that's an implicit way of taking complexity of models into account.
I know that people say that, but I already said in Peterson, I don't believe it. Very clear, the model, every weird parameter that you add improves the performance. So I think they're not really correcting for complexity.
Yeah.
But maybe there's a point of debate, maybe talk later.
Now, cross-validation is an intuitive way of taking complexity of models into account, but you're right in the sense that it has no rationale. It's an implicit way. So we don't know exactly how the complexity of a model plays a role when doing prediction in cross-validation. So I agree with that. In the other two experiments, we did not rely on cross-validation. We used Bayesian techniques that also takes complexity into account. But here we had not very extremely complex models. I mean, only the ones that I showed to you.
Okay.
But the nice thing of these two experiments is that we had some standard theories that are very prominent in the literature, and the theory that we suggest outcompetes these models, at least in these two experiments.
Inet?
Thanks, Joerg. I just wondered about the decision field theory. So I saw that in your graphs, it predicts like the same, no differences, right, between the different conditions. And I wondered because there are so many diffusion models that were proven. So in fact, I know someone that showed that that the diffusion models like leaky competition accumulator models and some other types, that they do not assume this independence, right? So this is something, at least that I know for the perceptual decision making task, that people already know to compare and to use this dependency in the model, right? So I'm kind of afraid that at least for this comparison, it's not completely fair, in the sense that the models, there are much more advanced model now that this area promotes, that will and should probably, I don't know about the huge data set that he showed, and of course the results are really impressive, but as I said, so I don't know, it will for sure predict these differences. I'm quite sure about that.
So the decision field theory is in principle also sensitive to the context, and it also takes differences into account. And to that, I mean, that's also a component that our theory shares with decision field theory. But what we do is we have noisy probability representation and noisy representation of differences. And that's a difference to decision field theory. And that might be the advantage of our model in comparison to decision field theory. So in decision field theory, for instance, you take the probabilities as they are. You take objective probabilities. So you weight each comparison exactly according to the probabilities with which these outcomes occur. Whereas the theory that we have allows to do comparison and just, I mean, in the extreme, our model allows that you disregard the probabilities and just do comparison and count how often one option is better than the other. And
So in essence,
that's the extreme way of applying this idea. And that's something that you can't do with decision field theory unless you also change. I mean, in principle, one could also implement this with decision field theory. That
yeah, unless you add noise, right? So you can
you could
like
also
noise.
add noise to these comparisons, but that's not, well, as you said, there are different versions of decision field theory. Others have, worked on different ways of it. But in principle, at least the original version does not include noisy representation of probabilities.
Thanks. I do think that they do. So they do have this idea of noisy stimuli and how you use it. So the fact that nobody did it is really, like, for probabilities might be something that need to be changed. But I think that you do have this conceptual idea there. Anyway, just a note, because I didn't understand exactly what you did, but I understand now that what you're saying is that the most important thing is the noisy perception of the probabilities. Like, that's the core of the model that gives, right?
It's an important component. What I like about this model is that on the one hand, it has this heuristic idea of comparison of outcomes, and like a tallying rule, just checking how often one option is better than the other. But at the same time, it's represented in a mathematical fashion such that you have three parameters, and depending on on these parameters, you become an extremely heuristic process, or you can also represent probabilities and utility differences with high precision. That's also possible. So therefore, this model is relatively powerful.
Okay, we will continue
Thanks.
in the informal
Thank you.
discussion. So this was the end of the formal talk. So thanks, Joerg. And we're gonna move now to the so people that have something to do now have to go should go now. And if you want to stay for the informal discussion, you are welcome to stay. We have another 15 minutes. So Shachar,